Okay, so I'm going to go ahead and get started on our HL 1.1 Advanced Trigonometric Identities. So the first thing I'm going to walk through, just in case you've forgotten or need a review. So cosecant, secant, and cotangent are the reciprocals of our traditional trigonometric identities. The easiest way to remember which one is which is to obviously memorize them, but there's something called the third letter rule. So the third letter of cosecant is S, and so its reciprocal is 1 over sine, which starts with an S. And with secant, the third letter is C, which gives us 1 over C, or 1 over cosine. And then lastly is cotangent, 1 over T. So that would be 1 over tan, which, just in case you forgot, tan is the same thing as sine over cosine. So if we were to come up with the reciprocal, that would be cosine over sine. So those are the same thing. And then in terms of opposite, adjacent, hypotenuse, when you think of your sides of a triangle, this would be adjacent over opposite. Secant would be hypotenuse over adjacent. And then lastly, hypotenuse over opposite. Okay. So those are our identities. Again, this should just be a review. So here we're going to look at exercise 6J. The problems are in an image on the other side in Google Classroom. And I would like you to do the rest of the problems that I don't do, and then turn in a picture of that on Google Classroom, okay? But first I'm going to go through just a couple of the examples here. So problem number 1 is secant of pi of 6 minus cotangent of pi over 3. So the first thing is to remember that secant is the same thing as 1 over cosine of pi over 6 minus, this would be 1 over tan of pi over 3. And you should know these from your unit circle, because I know you all remember your unit circle. So this would be 1 over the square root of 3 over 2. And then this could be also rewritten as cosine pi over 3 divided by sine of pi over 3. And the reason why I wrote it this way is because I think it's easier to read. So this would be 2, let me switch colors real quick. This would be 2 over square root 3 minus 1/2 divided by square root 3 over 2. And for those of you that need a reminder of how to simplify this, we have 2 fractions being divided. And so then we're going to use keep, change, flip. So we would keep 1/2, change the sign to multiply, and flip the second fraction. Our 2's will cancel, so we're just left with 1 over square root 3. So then we have 2 over square root 3 minus 1 over square root 3. And that leaves us with just 1 over square root 3. But remember that we can't leave an answer in this form. So instead we need to rationalize it, which means we're going to multiply by 1 in the form of square root 3 divided by square root 3 That way the denominator is rationalized. And then our final answer would be square root 3. And then the square root of 3 times the square root of 3 is the same thing as just 3. So this is our final answer for the first one. Okay, next, we're just looking to simplify the following equation. So we have cosine theta times tangent of theta. This is the same thing as cosine of theta times tangent of theta can be rewritten as sine of theta divided by cosine theta. Then we can see that our cosines cancel, and so this would just be sine of theta. So all of those problems in section 3 are just rewriting the different equations so that they cancel and simplify really easily. Okay, lastly, we have cosecant theta is equal to 13 over 5. And remember that cosecant of theta, when we wrote it in terms of opposite, hypotenuse, adjacent, would be hypotenuse over opposite. So then I know that I can use Pythagorean's theorem to find the missing side. So it would be 5 squared plus the adjacent side squared is equal to 13 squared. And that means that adjacent squared, when you simplify it, is equal to 144. So therefore, just the adjacent side is 12. Okay, and then it wants me to write down what cosine of theta is. Now remember, cosine is adjacent over hypotenuse, which is, in this case now we know, 12 over 13. And then they also asked for cotangent, which is adjacent over opposite. So that would be 12 over 5. And that's our final answer. Pretty straightforward. Lastly, I'm going to now flip to the back of your notes. We're going to talk a little bit about these identities. Now, you used these identities in a flip book at the very beginning of last year, but I don't feel like collectively you remember them or know how to use them. So the first thing we're going to work through and the different ways you can see the Pythagorean identity. So that's sine squared plus cosine squared equals 1. So if we were to divide by sine squared, so dividing everything by sine squared, we would end up with 1 plus cosine squared divided by sine squared is equal to 1 over sine squared. And if we were to rewrite this, this is the same thing. Using those identities we learned on the last page, this is the same thing as 1 plus cotangent squared is equal to cosine. Is equal to cosecant. Squared. So this is just the same equation written in a different way. Same thing applies to the second one. We would have sine squared divided by cosine squared plus 1 equals 1 over cosine squared. And that can be rewritten as tangent squared plus 1 equals secant squared. Okay, so both of those are the same equation, just written differently. And then also attached to your Google Classroom page is exercise 6L. And if you work through those problems, that will help you end up with your compound angle identities. I'd like you to try that first, and then you can come back and check your answers here. So go ahead and pause your video and give this a shot. Okay, so now that you've done those problems, the answers you should have gotten were sine A, cosine B, plus cosine A, sine B. And just so you don't have to watch me write all of these out, I'm going to pause the recording and then fill in the rest. Okay, so here are the rest of the compound angle identity formulas you should have gotten by completing exercise 6L. I'll give you a second to copy them down, / you can just pause the video, and then I will do the same thing for the double angle identities. Okay, so now looking at the double angle identities, I'll give you an opportunity to copy those down as well. Again, this is really designed for helping make problems easier. We'll take a look at some of that during class in addition to working on your Delta Math. I would recommend taking a look at your Delta Math beforehand in this case. If you don't, that's okay, but I would strongly recommend it. So if you look at your Delta Math beforehand, we can use class time for Delta Math, but also to look at some IB style questions to see what they expect from you with questions like this. But that is your lesson. Make sure, if you haven't already, that you go ahead and comment that you watched the video.